Number 20C, the identity looks like this. So what we're going to do is we have, in the last case, I converted it the right-hand side, left-hand side. In this case, I'm going to convert the base q squared. So this is my major issue right now, is that my q here and q here don't match the q squared here. So I'm going to convert the right-hand side and use change of base formula in the denominator, and I'm going to change that to base q. And in the denominator, this is going to be log base q of q squared. Well, that's an identity. Okay, this is equal to, that's just going to be equal to 2. And that should show up in my numerator. So when I do that in the numerator, okay, so I rearrange that fraction on the right-hand side here, I get in the denominator, I'm going to have log base q of p, and in the numerator, that's going to work out to be just 2. That's an identity. And on the right-hand side, well, I have a common denominator. I can just add that together, and I'm just going to end up with a common denominator of log base q of p. 1 plus 1 gives me 2. Left side and right side match. I've proven that identity. For D, looks like I flipped the base, and that is same as flipping the argument. Well, let's see. Let's just use our change of base formula here. Log base q of p, and this is going to be log base q of 1 over q, okay, which is same as q to the power negative 1. So what ends up happening is in the denominator, that just works out to be negative 1. Well, negative 1 in the denominator really is the same as negative 1 in front. And so what ends up happening is I get log base q of p, let's make this a little bit cleaner here, and that's going to be to the power negative 1. Well, log base q of p to the negative 1 is 1 over p. So I have my right side equaling my left side. My identity is proven. Now, this actually does make sense if you think about it, because if you think of an exponential expression, I have my base a, I have my argument c, and I have my exponent x like this. Okay, so if I were to, in this case here, I'm just going to color this the same. So there's my base, and here's my argument, and here's my argument. And basically what's saying is this: if I flip this fraction, if I flip that fraction base to 1 over a, I should have a negative power. But I can balance that off with flipping my fraction here. These are actually equivalent. I don't change my power when I do this. Okay, and that's essentially what I've kind of done here. I flipped the base and I flipped the argument, and I keep the exponent the same. So this does work.